Hey guys, I am going to be doing lesson 2 today. It is the same packet as lesson 1 and we're going to be doing factoring using GCF, dots, AM method, AC method and grouping. Okay, so I'm going to get started with number 13. So here, if you look at this, is there a GCF? That's the first thing you must always check. So yes, there's a GCF, which is 2. So I'm going to factor out 2. What am I left with? And actually zoom it in. So you're left with 4x squared plus 21x plus 5. Now you want to think about this part only. You want to focus on just this part, right? Now again, identify the structure of the question. There are how many terms? There are 3 terms. And how do you factor a 3-term polynomial? Look at your leading coefficient. Your leading coefficient is not 1. It's greater than 1, right? So it means you're going to do the AC method. So you need 2 numbers that multiply to 4 times 5 is your A, which is 20, and add to 21. So multiply and add. So if you guessed it, it is 20 and 21. Let's do this. So what do? I'm going to keep my GCF out. I'm not going to worry about the GCF. So I'm going to write my first term. What you do is you're splitting the middle term into your 2 factors. We said what were the 2 factors? 20 and 21. Sorry, 20 and 1. So this would be plus 20x. You're just splitting it. 1x plus 5. Look at this. Doesn't that add up to 21x? So you're not changing the question. All you're doing is splitting the middle term. Now, you factor by grouping. So what do? You have the first 2 terms. Look for the GCF of those 2. So that would be 4x. 4x. And then I'm left with x plus 5. Keep the sign. This is plus, so I'm going to bring down the plus. And 1 is the GCF, right? You always have 1 if nothing else is common. And you should be left with the same thing. Check here. This is x plus 5. This is x plus 5. This is how you know that they are, you're doing the right thing because they are both same. So now all you do is factor out. I'm going to keep changing colors. So this will be what? X plus 5 and 4x plus 1. You're done factoring. We're not solving here. And you're going to remember to bring down your GCF. If you're in doubt and your question is in just one variable, you can actually put this equation in the calculator in y1 and the other one in y2. And you should get the same set of values. Okay, let's try number 14. And I highly recommend you can pause the video, try it on your own, and see if your answer matches mine. Okay, so again, is there a GCF? Yes, I see a GCF. There is what? X is common in all, and there's also 2. So 2x. What are you left with? 7x squared plus 73x plus 30. Right? Again, if you identify this, your leading coefficient is not 1. It's 7. So what do? You're going to split the middle term, right? So again, look for 2 numbers that multiply to 7 times 30 is 210 and add to 73. If you can think of your head, go to y1, type in 210 divided by x, and that will give you all your factors in the table. So you can look it up like that, or I actually know it is 70 and 3. So I'm going to again split the middle term into my 2 factors, 70x plus 3x. Again, this is 73 and isn't 70 plus 3 73. So I'm not changing the question. You can't change the question. I'm going to keep my GCF up there. I'm going to factor by grouping and then bring the GCF down for once and all. So now again, 7x is the GCF and you are doing x plus 10 plus, keep the same sign. Many people forget to put the sign. You lose points for that, guys, so be very careful. And this is x plus 10. Again, this is same, this is same. I know I'm doing the right thing. Factor that out. It's basically factor by grouping is doing GCF 2 times, right? it's completely factor. Always check, can I factor any of these binomials? No. So this is 2x. Bring down your GCF, and that's what it is. Again, if you want to pause the video, go ahead, try number 15. Okay, anytime you're working with these questions, you want to make sure your leading coefficient is always positive. It is not positive, so I know I'm going to already factor out a negative. What else? Is there another GCF? It is 2, negative 2. So what are you left with? 5x squared plus 7x plus 2, right? Again, your leading coefficient is not 1. You're going to split them 2 terms. So 5 times 2 is 10. And you need 2 numbers that add to 10. Multiply to 10 and add to 7, which is 5 and 2. So I'm going to take 5x squared plus 5x plus 2x plus 2. Check. They're the same. I'm just splitting the middle term into my 2 factors, right? Now I'm going to factor out the 5x. I'm going to be left with x plus 1 plus 2 x plus 1. Again, check. I got the same things inside, so it is right. And then I'm going to change colors. I have to remind myself. X plus 1, and then you're left with 5x plus 2. Can you factor any of these binomials? No, we can't. But you will find some questions that you will bring down your GCF, and that's your final answer. Okay, now let's go down to 25. You have to finish the rest on your own, okay? I'm just doing a few questions of each kind so you kind of get an idea of how to do all the other questions. So now, this one again, start with the GCF. Is there a GCF? Not really. So your leading coefficient is 1. So basically, then you do the AM method. You need 2 numbers that add to negative 4 and multiply to negative 45, right? So here you don't have to split the middle term. You can do it that way too. But if your leading coefficient is 1, you can set up 2 brackets and just write the answers. So this is going to be A. And since, look here, it's negative 45, so the both signs going to be alternating. And what would it be? It's going to be 9 and 5, but which one would be positive or negative? Over here. Between 9 and 5, which is the bigger number? 9. Since this is negative, your middle term is negative, it's going to be negative 9, positive 5. And that's it. Again, check. Can I factor this any further? No, I can't, so I'm good to go. Number 26, it's again the AM method. How do I know? My leading coefficient is 1. There's no GCF. I need 2 numbers that add to 9 and multiply to negative 22. And now think about it. It's 11 and 2. Yep. So now again, between 11 and 2, which one is bigger? 11. This is positive, so it's going to be plus 11 minus 2. Multiplication is commutative. So it's okay for you to write it as x minus 2 and x plus 11. It's not wrong. But if your signs were switched, then you would be wrong. And if you're in doubt, again, put this one in y1, put this in y2. And if you get the same answer or the same set of tables, the same graph, then you are good to go. Okay, again, AM method. My leading coefficient is 1. Give me 2 numbers that add to 14 and multiply to 49. So it would be what? X plus 7 and x plus 7, right? This is actually a perfect square trinomial because guess what? You have 2 of these quantities. It's like, and the exponent is 1. Remember, in multiplication, when bases are same, you add the exponents. So I can write it as x plus 7 square. Okay, so these were really easy. They were like AM method. You can really be very quick with these. You don't have to stress too much about them. Okay, I'm going to turn to the next page. I'm going to do number 42, 48, and 49 with you. So number 42. Okay, again, start with looking for your GCF. There's no GCF. Now I see how many terms? 2 terms. So if it's 2 terms, you're going to be factored by what? Dots, right? Check. Are they both perfect squares? 81 is a perfect square. X to the 4th is a perfect square. How do I know variables are perfect square? If they have an even exponent. So 4 is an even number and there's a minus sign. So I'm going to set up 2 parentheses. You're basically taking the square root of each part. So it's going to be 1 will be plus, 1 would be minus. It's going to be 9. The square root of 81 is 9, right? And this would be x squared and this would be x squared. Again, check. Can these be factored further? I cannot factor this because this is plus, so it's not difference of two perfect squares, so this is not even in the process of being factored. But look here, 9 is a perfect square, there's a minus sign, and x squared is a perfect square, so I can factor that. So I'm going to write my first factor as it is, and this will factor to 3 minus x, it's dots again, and 3 plus x. If I was to do the way I was doing it before, I'm going to set up two parentheses, one with the plus, one with the minus. Be very careful, you cannot transpose. 9 is my first term, so square root of 9 is 3. It will go in the first place here. Okay, that's one mistake I often see people do that. And now check again, can anything of this be factored further? No, it cannot be, so we're good to go. So I said the next one I'm going to do is 48. Again, pause the video anytime you feel like and go for it. So now, is there a GCF? Yes, there is. What is it? X. What are you left with? X plus 5. Can you factor this further? No, not really. So that's it. That's your final answer. 49. Again, is there a GCF? No. So two terms. Check. Are they all perfect squares? 4 is, x squared is, 25 is. Is there a minus sign? Yes. So it is dots. Set up two parentheses, one's with the plus, one's with the minus. And now do the square root of the first one. So it'll be what? 2x and 5. Again, check. Can you factor any of them further? No, not really. So that's what it is. The last question that I'm going to do is number 102. It's on the last page. Okay, so here again, always start with the GCF. Is there a GCF? No. Then identify the structure. How many terms are there? There are two terms, and check if they are dots. So 16 is a perfect square, x to the fourth is a perfect square, 81 is a perfect square, and there's a minus sign. So I can do dots. I'm going to set up my two parentheses with a plus and a minus, right? So keep the order. 16x to the fourth is your first term, so square root of that would be here. So it'll be 4x squared, right? And 81 is what? Square root of 81 is 9. Now again, always check. This one we can't factor over reals. So what do? I will look at this one. Can I factor? Again, two terms. They're all perfect squares, and that's a minus sign. So I'm going to bring down my first parentheses as it is. And this one would be plus and minus. Square root of 4x squared is 2x. And this would be 3. So that's your final answer. If you left it up here, this will not be factored completely, and if it was a multiple choice question and you picked this answer, you would be wrong. It's not, because it always will want you to factor completely. Okay, so please make sure we always check our binomials, our trinomials, that if they can be factored further. Good luck with your homework.